Guys see my screen? Okay, thank you. Um, so let's just think about it. Just like the program assignments in your, program assignment 1. You have a list of dictionary and you wanted to search some words, whether it's in this dictionary, but different to your current dictionary list. If you're open your dictionary.text, I think you'll figure out all of the words in that dictionary is lowercase. But in reality, maybe the first initial character should be uppercase, right? The maybe it's just randomly uppercase mixed with lowercase. So if you want to search words in such a dictionary, what are you gonna do? Yeah, so maybe a simple way is just to check whether the current lowercase is existed in the list of the dictionary lowercase, right? So you want to change all of the words in this dictionary, in this list with a lowercase version, right? And you build up a new dictionary, a new list, and then you search it in this list. But just think about it. You have a memory space of one dictionary, that .txt file, and you create a new list that should be double your memory, right? You have a 2 list now. So what is the efficiency way? That is the generator will do. It will check the words one by one. That is the generator can help us. So we can check these words by running such a script, but what if we check these words once by once? Just check the lowercase. The first initial try, we build a list of these lowercase words. What if we just check each word, the lowercase version of each words in this list, rather than just build a new one? So let me check this one. Yeah, so this is the way to check this. But what if we build a what if we build the lowercase function by checking its lowercase? If we run such a way, the return would be false. If we check the font characters, the loop will run from "I told you I do not need a font." Yeah, because in this line, the line 7, for the words in return lowercase words, this is still a function, but not a generator. Yeah, in this line, if the first word is not the if it's not the words here, the font words, the function will be paused. So what's going on here? The problem is that the return statement in line 3 above terminates the execution of the for loop. So return lowercase returns the first words "I" and terminates. So what the generator do is just change the return into a yield. So you see in this version, we change the return into yield, and then the function will pop up a check for each words by words. So when the for loop in here loops to the words phone, it will return the true. Here's some example to help you to understand the generators well. A print. It may not help for building up any functions, but it do help for you to understanding what is a yield or a print by compare this to snippets. So what generators can do? So based on what we discussed, actually I think it's just generate some pop up some new values one by one, rather than just build a new or occupy a new memory space. So you can build up a list of even number rather than build a list, but by using even numbers, by building such a generator function. I think, I don't remember, but if I'm wrong, please just correct me. I think a generator is actually an iterator. For iterator means, you see here, we define a generator's even numbers. So we use these iterators here in this for loop for n in even numbers. It's like for n in a range, whatever, 6, right? So this range 6 is I think is a iterator. So similar to that, a generator is an iterator. So that means it can generate any numbers by iterative operations. Yeah. So you use this generator in this line, in this for loop. You print this even number n, and by each operation, by each loop, you pop up a new values by 2 times I. So after this iteration, your I plus a new number plus 1. So if it's yeah, right. So this is the way we build such a even number. So similar to this, we can identify whether it's it's divisible by 2, 3, and 5. Yeah, we can build such a generator by this operation, just by this line, right? Similar to this one, when you're print this out, use this for loop, you can get this series of numbers, but not a list of numbers, right? And also you can ask the generators to say when to stop these generations. So for example, like in our words list, if you're giving a words equals to a stop words, then you stopped this generation. You just return an empty, else you yield something. So if you want to stop at the words here appears, we just insert such a mark here, and then the generation will be stopped before that one. I like to eat, so no appears output. The following two is about the permutations and the subset. I won't cover I will post this link to you guys after these lectures, and you can try out. So the basic idea is the professor built up a generators to generate some permutation patterns by using this principle. And the same things here. You can calculate or build some subsets of a set by using generators. Yeah. So basically, this is some supplementary lecture about the generator.